AO is the hyper-parallel computer. It's a decentralized computation environment that allows you to run any number of processes in parallel at the same time. Previous decentralized compute systems have either enabled large-scale compute or verifiable compute. AO lets you do both at once. Smart contracts are great because they enable you to have verifiable computation without trust, but it isn't actually very much computation. A TI-83 calculator, the kind that you would get in a classroom when you were a kid, does over 5 times as many instructions per second as the entire Ethereum network, with tens of thousands of computers and billions of dollars at stake. AO doesn't just let you do more verifiable compute, it lets you do any amount of verifiable compute. This is a bold claim, but we can back it up. First, let's understand how smart contract systems generally work. In Ethereum, everyone on Earth is essentially sharing the same thread of execution, and we're globally locking the memory space when we do so. So when you want to interact with the system, I can't interact with the system. Every person is essentially interacting one at a time, like a massive global queue. The last generation of blockchains kept the global memory space shared between all users of the system, but they allowed you to lock subparts of this, local locking, we might call it. This is definitely an improvement, but it's nowhere near sufficient. Essentially, everyone on Earth is still queuing to use one computer, and it doesn't matter how much stake and how many resources we bring to the network, that's still just one computer. Some architectures like rollups and app chains allow for more threads of execution to be executed at the same time. This is definitely a step in the right direction, but it's only a partial solution. Each of these individual threads is hosting many contracts that are sharing the same memory space. That means that each community or user base is still competing to access one shared resource. AO goes a different route. Internet services scaled not by making ever faster individual computers, but learning to harness many computers in parallel to serve any number of users simultaneously. We call this horizontal scaling rather than vertical scaling. AO does the same thing. Instead of chasing an ever larger global shared state machine, AO focuses on enabling any number of parallel processes to happen at the same time, and then allowing these processes to coordinate by sending messages between one another, just like computers in data centers and on the internet send packets in order to work together at scale. All of these processes that are running inside AO then roll up onto Arweave's scalable on-chain storage as their permanent host. In fact, none of this would be possible if we hadn't spent 6.5 years perfecting the design of an on-chain storage system that scales to arbitrary sizes. That's really the key that enables all of this to occur. Instead of being a homogeneous network, AO is actually constructed of 3 different subnetworks, as well as Arweave as its base layer. Let's run through it. When messages first enter AO, the user sends them to a messenger unit, or a MOO for short. Users can pay the MOO in whatever form that they want, be that tokens, fiat, or even perhaps cows. When it receives a message, the MOO is responsible for finding the right scheduler, kind of like a sequencer, but a little bit more complex, in the distributed scheduler network. Basically, it allows you to bring your own scheduler. Schedulers can take any form that the user likes. They can be either decentralized, staked, or even entirely different blockchains. You could use Bitcoin as an AO scheduler without modifying the core data protocol at all. Schedulers have 2 simple jobs: give a sequence number to each message and ensure that it is uploaded to Arweave directly. After the scheduler has assigned our message to a slot and guaranteed its upload, the messaging unit will request that a compute unit, or CU for short, finds out the result of the operation. If the result contains another message, the process is repeated, pushing each new message in parallel around the machine. An AO token staking contract then keeps the behavior of each of these units in check and economically secure. This architecture is relatively simple actually, but it's unbelievably powerful. And critically, it solves the core problem of blockchain scalability. If you add more units to each of these distributed networks, they gain more power. Each of these subnetworks is a peer-to-peer marketplace where demand for service pushes up the incentive to bring capacity online, and competition pushes down prices for users. And fundamentally, this is a computation system that will never need a fee market. When you use a traditional blockchain like Ethereum, Solana, Bitcoin, you compete with other users to gain access to a limited bandwidth. From a computer science perspective, what you're essentially doing is queuing up to use the resources of the network. And so actually, it's not like you're paying a large amount for the compute itself. You're paying a large amount to be the person that can edit state of the system at that point in time. This lets you build smart contracts that run like normal apps, extremely high throughput with great user experience. It also enables developers to build in an unconstrained environment. It lets you build things like large language models, that's AI, running inside smart contracts. You can even build things like decentralized recommendation systems and indexes for social media. This is the type of ability that will allow us to create trustless web services at scale, like actually this time. The testnet of AO launches today, but some people have already been building on it for a few weeks. Let's take a look. AO is so scalable that the sensible way for developers to start interacting with it is to boot up a new process inside. So that's exactly what you do when you onboard with the system. It's like your own personal server inside this new internet. Because my server is separate from your server, we can do any amount of compute on each of them, and they operate independently. So one is cool, but why not for fun? We'll start up 100 more. AO is just getting started, but already you will find a new world unfolding inside it. There's tokenized chat rooms where people are discussing what to build on the system, arenas where dozens of parallel autonomous bots are playing to outcompete each other in virtual worlds. You can even bet on them. Other processes are indexing Arweave and providing provably neutral recommendations for decentralized social media applications. And some people are just trading tokens. What do you know? And now we have 100 new processes inside the computer, all of them permanently stored on Arweave. But here's the kicker. All of these are running in parallel. Yes, each process is like a contract, gives you the same guarantees as a contract, but each can run individually at the speed of a single thread. And if we ever needed more, we could just spin up more. Collectively, these processes can address 400 gigabytes of smart contract RAM, limited only by the WebAssembly virtual machine. Use a different virtual machine, and you can get even more address space. The testnet launches right now. You can check it out at ao.arweave.dev. One of the exciting things about AO is that you can plug any virtual machine into it that you want. EVM, Solana's virtual machine, SVM, WebAssembly, or any other kind of deterministic computation device. This is because at its core, AO is actually an open and flexible data protocol for the storage of computation logs on Arweave's permanent ledger, not a network in itself. It gives rise to a network, which gives rise to a staking system on top, in kind of a layered approach. The base layer of AO aims to do for compute what the internet protocols did for data transmission, offer a standardized, open mechanism that suits all types of use cases. Just as you could plug any new type of machine into the internet and exchange packets with other participants, AO lets you plug in any new type of machine and send decentralized messages between them. As well as the core data protocol, node implementations, and testnet, we're also launching a decentralized operating system for AO today. We call it AOS. AOS is simple, powerful, and fun to use. It's genuinely actually fun. It makes working with messages easy and intuitive. You can build with AOS using Lua, the language that millions of devs use to mod Roblox, Minecraft, and also to write core internet infrastructure. If you're a developer, you can learn to use Lua in 15 minutes. It's one of the most simple, intuitive languages on Earth. This is why we chose it. While you can program AO using Rust or Solidity if you want to, AOS uses Lua because it gets you thinking at a high level of abstraction. It doesn't bother you thinking about memory or borrow checking. It just gets you thinking about the core computation in your programs. It's simple, elegant, and clear. We gave a demo of AO and AOS to a crew from Arweave India in Bangalore a few weeks ago. Within days, they had already built projects that far exceed the bounds of traditional smart contracting systems. For example, Orbit, an Oracle system for a smart contracting network, AO, that allows you to do things you never could in another system. For example, It lets you grab whole HTTP web pages and load them into your contract for processing. Not just crypto prices anymore, but real data feeds, access to the open world.
That's right. At Orbit, we built an oracle that can use and store full HTTP requests. It's the bridge between AO and the internet. Accessing that much information would not be possible without using Arweave's scalable storage. Here is how it all works. We have an AO process that fetches JSON data from a URL. The user can send a request to Orbit's AO process with just a single command. Once the module sends back the fetched data, we see the message in our inbox. And when we feed the message ID to any Arweave gateway, we can see the data.
Thanks, Ayush. One of the most fun parts of working with AOS is its development flow. It lets you prototype, test, and publish right from your console. The best way to show this is just to try it. Patrick, why don't you walk us through it?
Now that you know what AO and AOS is, let us begin by diving into the rabbit hole with the Getting Started tutorial. In this tutorial, you'll be met with a couple familiar characters, Morpheus and Trinity. But these aren't just normal characters. They're both your guides in this journey, as well as autonomous AI agents built directly into AO. Now, let us begin. The first thing I need to do is open up my terminal. I'm going to maximize it. And I'm going to make it nice and big so everybody can see it. I'm going to start my process by typing in AOS. My process has begun. Now, let's go ahead and just send a message to the autonomous AI agent, Morpheus. I'm asking, Morpheus, are you there? I have received the message back. Let's see what it says. He says, yes, it's me. I see you finally broken free, but are you really ready to see how far the rabbit hole goes? Your next step you'll find inside of the AO cookbook. This only marks the beginning of the journey that you are going to encounter in the interactive Getting Started tutorial. Throughout this tutorial, these two autonomous AI agents, Morpheus and Trinity, will continue to pose challenges that will grow your ability and understanding of operating inside of AO. If you want to continue down this journey with me, you can find me inside of the AO cookbook. I look forward to seeing what you learn and what you can build inside of AO.
Thanks, Patrick. The AOS console is fun and easy to use. But what if you prefer to use a graphical user interface? Well, the BetterIDEa crew has you covered.
And usability is at the core of a good developer experience, which is why we built BetterIDEa. It is an online platform crafted for the AO ecosystem. It's like Collab for Web3 developers, offering familiar intuitiveness while seamlessly integrating with AO's on-chain computational engine that lets you write clean, efficient contracts in Lua.
To show you the capability of AO in action, here's a quick demo. This is our notebook interface that executes Lua code on AO. With this, you can easily build and run applications like the one we have here, a chat room. When we send a message across through a particular process, it updates all of the chat room member processes to display the message we just sent.
Earlier, I mentioned that AO lets you build new types of smart contracts that wouldn't be feasible on traditional systems. Arweave has already been used to store proofs from other decentralized networks, but AO lets us take this further. The proofs themselves can now be validated natively at any scale on-chain. Take the Lightseed network, a decentralized and economically secure bundling system for Arweave.
Which is what we did at Lightseed. We were able to trivially solve otherwise tough problems involving optimistic caching and bundling of transactions in order to offer faster, cheaper, and more reliable way to upload and handle data. In practical use, the data is sent to bundler with AR. It is then bundled up and uploaded to the network. In this case, we trust the bundler to refund the excess AR back to us. Lightseed is different. It works by running a network of bundlers on AO where each bundler is required to stake tokens. When a user makes a request, a bundler is randomly selected, which then uploads the data to Arweave.
Thanks, team. At Forward Research, we care deeply about building real protocols. Protocols are exciting because they allow us to offer services that would never otherwise be possible. For example, the Arweave network runs a decentralized storage endowment whose mechanism and risk model is fully transparent. A centralized organization can never be able to offer you the same guarantees because you would always need to trust the execution of its managers over time. Most smart contracting networks attempt to entice developers and users to build on top of them while they are essentially in an incomplete state. This means that users and devs must trust the creators to execute a roadmap to essentially complete the protocol. Where are the guarantees here? With AO, we're trying to do things differently. The mainnet of the protocol we will ship will be full and complete. We anticipate that only Bitcoin-style updates will be required in the future. Minor upgrades with the core features and rights of users remaining unchanged over time. There's no trust me bro roadmap here, just a full and transparent protocol that you can audit and decide if you want to use yourself with complete knowledge of the system. In order to support this approach, we are also building a coalition of different organizations, each staked into the long-term success of the network. There's no core team here per se, just a decentralized ecosystem from day one. In order to support this approach, we are also building a coalition of different organizations, each staked into the long-term success of the network. This coalition is open to any and all to join, each gaining an ownership stake in the protocol. Devs in this coalition are already starting to build. Tate, why don't you tell us what Community Labs has been creating on AO?
Thanks, Sam. At Community Labs, we've been building on AO for the past few months, and we've been blown away by its power. So much so that today we're excited to announce 2 new protocols, Astro, a new type of stablecoin, and Bark, AO's first exchange. Let's take a look at Astro. Stablecoins are crucial to blockchain adoption because they provide liquidity for users and developers. To bring this to AO, we built Astro. Astro is an over-collateralized stablecoin that is backed by Arweave tokens and lays the foundation for money markets to exist natively within AO. We think that this will be hugely popular among the first trading pairs for AO tokens as well as Arweave token holders. You'll be able to trade Astro and other tokens on Bark, AO's first decentralized exchange. Bark is the beating heart of the new economy on AO. It's structured as an automated market maker, enabling anyone to trade assets quickly and simply. But to do so, exchanges require low latency and high throughput, of which AO takes care of both. Pairs live on their own processes, meaning you can have any number of them running in parallel, resulting in settlement speeds far outpacing that of centralized exchanges. Because AO has a unified messaging format, anybody building an EVM or Solana's virtual machine on the network can interface with Bark. This level of composability allows developers to comfortably build on Bark in any programming language and even to build autonomous agents on top. Your trades can live on Bark, and so can your bots. Woof. Bark is available starting today on the AO testnet, and Astro will be launching soon. Check it out at bark.arweave.dev and follow us on X at Community Labs to stay tuned.
Thanks, Tate. One of the most exciting parts of AO is its universal messaging format. It lets anyone plug in new and existing deterministic compute systems, sending messages to any other participants in the ecosystem seamlessly. Think of it like a universal language for blockchains, kind of like a Rosetta Stone. This means it can also unify existing smart contract layers, being a universal bridge between all of them, with Arweave as a backbone. For example, Jakob, Marcin, why don't you tell us about how Warp is integrating with AO?
Thanks, Sam. Hi, I'm Jacob, founder of Warp Smart Contracts, responsible for the technology.
Hi, I'm Marcin, co-founder of Warp. I take care of business development, marketing, and go-to-market.
Warp enables Arweave builders to create smart contracts on top of the storage chain. We've been building the platform for over 2 years, and it's currently used for a wide scope of applications.
It can be utilized for simple cases, like tokenizing the content in the form of atomic NFTs. On the other hand, it also enables complex projects to act as a base layer for distributed databases.
Warp will work within the AO ecosystem as a separate type of process, maintaining all the custom features requested by our users, while benefiting from the scalable AO infrastructure and interconnectivity with other processes.
We're excited to join the coalition of Arweave builders, bringing to the table our experience of bootstrapping the smart contract ecosystem, helping to onboard new projects, offering necessary support to developers, and growing the community of users.
Thanks. But it doesn't stop there. MEM, another compute network on top of Arweave, is also bringing EVM to AO. Ben, why don't you tell us what you're building?
MEM is a serverless functions platform for Web3 developers to go beyond the limitations of deterministic compute and integrate off-chain APIs and traditional web services. MEM is able to send messages that trigger actions inside AO contracts to initiate token transfers, mint assets, and use Arweave's token ecosystem. MEM can act as an open compute oracle for AO, running non-deterministic programs and accessing any data on the internet. This allows AO to break out of the scope of deterministic verified compute and access oracleized data sources, which open up new use cases like reading data from other blockchains into AO or running traditional Web 2 software inside the system. And now over to Outprog, who will talk about how Evervision and AO work together.
AO is a decentralized computing environment based on Arweave, supports countless parallel processes, and near unlimited computation power with minimal trust. I proposed the SCP theory in November 2020, which core idea is off-chain computing and consensus data. With AO's security rooted in decentralized data layer, fostering trustless communication among SAP apps. This global decentralized computer allows for dynamic allocation of computing resources. Every pay integrating AO transforms into a hot-swapped process within the AO network, offering instant zero-fee blockchain payments through BetterIDEa make Web3 easy. This integration acts as cross-chain capability across the AO network, enhancing application interoperability and enabling seamless BetterIDEa usage. AO will also empower Everpay, allowing more SAP application messages to be verified on Everpay, truly achieving the combination of decentralized applications.
So that's AO, the hyper-parallel computer. There's still so much more to say about it, but why don't you just explore it for yourself? Join us on the testnet at ao.arweave.dev. See you there.